In this tutorial, we're going to show you how to create the basic steps for cutting this wingspar in the software. We'll start by setting up a job, whereby we'll then import vectors into the session. With those vectors, we're going to look at creating the toolpaths to cut this part out. And then finally, we'll show you how to save out the toolpaths to run them on your CNC machine. So let's go to File, Close. So we're going to start by creating a new file using this option here. Once we've clicked on that, that will open up our job setup form where we need to specify various parameters for the job size that we want to work with. In this case, we need to specify our job type to begin with, whether we're working with a single-sided part or we'd like to machine on both sides of our material using the double-sided part. In this case, we'll go with the single-sided option. Then we move on to the job size. This is where we need to specify the width of the part, the height, along with the thickness of the material that we plan to use. In this case, in width or in the x-axis, we're going to go with 8 inches. The height of this, or the y-axis, is going to be at 2 inches high, and the material thickness that I intend to cut into, or the z value for our part, is going to be 1/8 of an inch. So I'm going to type in 0.125 into the form there, ensuring that I specify the correct units to work with, inches or millimeters. You can simply just switch between like so. Then we need to specify our Z0 position, whether that's going to be on the material surface or on the machine bed. In this case, I'd like to set my Z0 on the material surface. So I'm going to click on this radio button here, and you can see that the form has updated and has put the red dot on top of our material at the material surface as we specified. And finally, we need to choose where our XY datum position will be, whether that's in the center or one of the 4 corners of our job. Currently, we can see the radio button is in the center. The red dot showing on the image here is displaying as the center of our material. And we can also see that represented in our actual job by this red square. So currently, X0, Y0 is here. Everything up the y-axis is positive here. Everything below this point here going down the y-axis is negative. Everything to the right of this point at the moment here is positive, and then everything to the left in the x-axis is negative. We're going to change our X0, Y0 position so it's in the lower left-hand corner. That way all of my values will be positive. So to do that, we're going to select this option here. So now X0, Y0 is in the lower left hand corner, and everything up the y-axis is positive. Everything to the right in the x-axis is also positive. So now we can go ahead and press OK. So now we're in a workable area where we have access to the Design tab, where we have many vector drawing and editing tools. Now here we're actually going to look at importing vectors from a file that's been created in another CAD program. So to do that, we come over to the File Operations section, and we're going to look at using this icon here to import vectors. And if we click on that, that will open up the Windows browser and enable us to search our machine for any vectors that we'd like to bring in. And so there are many vector files that we can bring in, and they are all listed here. Okay, so we're going to locate the file that we'd like to bring in. So that's this one here, the wingspar.dxf, and we could go ahead and press open. So at the top here, let's click on this icon to zoom active view to the drawing limits, and we can see the vectors have been imported here. We can see that the vector isn't totally positioned within our workspace, and this is down to the position of which they were originally drawn and saved out to in the CAD program in which it was originally drawn in. which is no problem, as we can look at using the alignment tools to get these vectors into the centre of our workspace. So with those vectors selected, let's go over to Transform Objects, click on the Align Selected Objects tool, and we're going to align those vectors to the centre of our material in X and in Y. And then we can close out and use this option here to zoom Active View to our drawing limits. So now that the vectors are imported and laid out correctly within our job space, we can now begin to assign toolpaths to the vectors to cut our part out on our CNC machine. So we're going to leave the drawing side of the software and we're going to switch over to the toolpaths. So to do that, we're going to use this icon here, and that will just undraw the drawing tab and then open up the toolpaths tab on the right hand side. If we wanted to switch back, we could simply use this icon here to switch back to the design commands, or if we wanted to temporarily look in our drawing tab, we can simply hover over the drawing tab here and that will just open that up. In this case, we're happy to move on and look at the toolpath side of things. Now before we go ahead and create any toolpaths, we must ensure that we set up our material exactly as we're going to set up the material to cut on our CNC machine. Now I can see at the top, indicated by these illustrations, some key information here. So we have our XY position, our X0, Y0, where that's set in the lower left hand corner according to our material. Z0 is on the material surface, our material thickness is 1/8 of an inch, and then we've got our safe home position at X0, Y0 with a Z position of 0.8, along with our safe rapids. Right then, so if we just go into the set option here, this will give us all of the information to all of those areas that we spoke about earlier. So here we can assign our material thickness, which we're going to leave at 1/8 of an inch. And we'll set the XY datum position. We're going to leave that in the lower left hand corner. Set our Z0 position. We'll keep that on the material surface here. Then we have the rapid Z gaps above the material where we specify a clearance and a plunge. Now these values are used for the tool to retract to before it moves to the next position in the toolpath. The important thing to ensure here is that these values are high enough that the tool will clear any clamping or hold down method that you may be using. So we're going to leave them both at 0.2. Then we have the home and start position. So this is just a value that you can enter to give the software a location to move the tool to before we start the cut. We're going to leave that at X0, Y0 with a Z gap above the material of 0.8. Then we could go ahead and press OK. So I'd like to take the vectors that we have here and I'd like to cut the outside of the outer vector and the inside of the inside vectors that we've got here. And so to select a vector, there are many ways. We could select a vector by clicking on it with the mouse, and then to select multiple vectors we can simply hold down Shift and click on each vector until they're highlighted in the selection. We could also look at just clicking and dragging a box around the entirety of the vectors in our job to select all of those vectors. We can click in the white space to deselect them, or we could simply press Ctrl A on the keyboard to select all of the vectors within our job. And so with those vectors selected, we can now assign a profile toolpath to them. So up the top here we go into Toolpath Operations. The profile toolpath can be found using this icon here, and if we click on that, that will open up the 2D profile toolpath form. At the top of the form we need to input our cutting depths. We're going to start by telling the software where we want to start from. In this case we want to start at 0, so you're going to leave that as 0. Then we need to tell the software how far into our material we want to cut into. Now in our case we know that our material thickness is set to 1/8 of an inch, so we can simply type that value in if we wanted to, or alternatively if we just delete that value in there And if we enter in the letter Z, followed by the equals key on the keyboard, the software will automatically fill in that field according to the material thickness that you set in your material setup form. So the next item in the form is where we need to select a tool. Currently we have no tool selected, so we're going to select a tool, and by pressing the select button that will open up the tool database. Here you have access to all of your default tools, you can add new tools, you can copy the tools, and if you'd like to learn more about the tool database, then please watch the Tool Database Guide tutorial, which you can find in the related videos section of this tutorial. And so the tool that I'd like to use is an 1/8 inch end mill. Here I can check over the parameters, the feeds and the speeds, ensuring they are safe and appropriate for the material and the machine that I'm using. In which case I'd go ahead and press select to assign that tool to this toolpath. And we can see that displayed in the tool list here. Next we need to choose how we're going to machine the vectors, whether that's on the outside, the inside or on the vectors. As I mentioned earlier, we want to machine on the outside of this outermost vector. We want to machine on the inside of the inside vectors to cut the part out. And so in this case, we're only going to use the outside vectors option here, as the software cleverly knows that if we have vectors selected inside of another vector, it knows to machine the outermost vector on the outside, and any internal vectors inside of that vector, it will machine those on the inside. So we're going to use this option here. Then we have the option to apply a ramp plunge move. Okay, so rather than the tool plunging down directly into the material, we can apply a ramp move where the tool will plunge in at an angle, reducing the wear of the tool itself as well as reducing the heat buildup on the tool. So we'll check that option here and we specify a distance. In this case we'll just go with a 1/2 inch ramp move, and then we can move on to the next option in the form where we're able to add tabs to the toolpath. And so tabs are bits of material that holds the part in place when cutting the part out. And this is very useful if you don't have a vacuum hold down system. And so in our example, we don't have a hold down system, so we're going to look at adding tabs to the toolpath. To do that, we check this option here, and that gives us access to assign a length and thickness to our tabs. In which case, we're going to go with a length of 0.15 and a thickness of 0.1 in this example. Then we use the Edit Tabs option, and here this will open up the Toolpath Tabs form. So here I'm able to specify a constant number and the software will automatically apply the tabs in place, or I could simply come over into the 2D view and you'll notice my cursor has a tab symbol next to it, and then where there is a tick displayed, it means that I can enter a tab in place. Okay, so I can go around and just click on the vector where I'd like to input the tabs. If I didn't like where a tab was, I could click on it again and that will delete it. I could take a tab, and if I wanted to move it, I just simply drag it to the left or to the right. So once you're happy with where you've positioned the tabs, you can close out of the Toolpath tabs form. And now we can just assign our toolpath with a name. So we'll call that profile. And for my own benefit, I like to include the name of the tool that I'm actually using in the name of the toolpath, purely just from a glancing point of view. When I can see the name, I know which tool I'm using for that toolpath. And then we can simply go ahead and press calculate. So once you've pressed calculate, the software will automatically open up the preview toolpaths form, along with automatically putting you in the 3D view to visualize what the toolpath is going to look like. Okay, so let's just put this in the ISO view. And so here we can see a wireframe representation of how our part is going to be cut out. Over here, these arrows represent our origin, our X0, Y0 position. If I use Control and hold down the left mouse key, I'm able to pan my material, and then using the scroller of my mouse, scrolling that away from me, I'm able to zoom in to our part. Right then, so we have a red line here, so anywhere you see a red line represents a rapid move, okay, so that's kind of like the travel. And then we have a light blue move, which is a plunge, okay, so this is where the tool plunges down into the material, and here you can actually see it's plunging down on the ramp, that's why we can see the diagonal lines there. Anywhere where the tool retracts up is represented by the green lines, that's lifting back up, and then it's travelling back to the next part where it will ramp in, and so on. And then wherever you see a dark blue line, that is the feed, okay, so that's it actually cutting away into the material. You'll see these areas here, we've got these lifts, so this is just where the tool is making way for the tabs, so that's where the tabs are positioned, and this pretty much represents all of the moves that's going to be cut within this part. So put that back into the ISO view. And so now we could look at creating a preview of this toolpath simulated in our virtual block of material to see how our part would look if we were to cut this out on our CNC machine. Over at the top we have the option to alter the appearance, so at the moment our block of material is showing as a Canadian maple appearance, and we have a list of preset materials that you could take advantage of, ranging from stone to metals to all sorts of woods. For example, we could go for a cherry, now alter that. If you wanted to, you could look at adding in a new texture by using this option here, whereby you just import the image file and then open that up, and then that would appear as your material block. So now we're going to look at previewing this toolpath. We have the option to animate the preview, whereby we can also draw the tool just to give us a real feel for how our part is going to be cut. We can alter the speed if we wanted to, so by using the slider we could just pull that up or down as fast or as slow as we wanted to preview it. And then we could simply use this option here to preview the selected toolpath, and you'll see that the software will basically create a simulation of how the part is going to be cut, and what you see here is exactly what you're going to get on your CNC machine if you were to cut this out. And this is the beauty of this preview, in that we get a good idea of what the part will look like, and so the wingspar will be securely held down to the material thanks to the 4 tabs that we've added in there. However, there is one potential problem that I can see, and that is that we have loose waste material on the inside cutouts, which could rip away, ruining the inside cutout. Also has the potential to damage the tool itself, as the part is loose, so the vibrations of the machine could move that loose part into the tool, and then saying that, it could also cause injury damage if the loose part gets flung out by the tool. And so to avoid any of these problems, we could just look at adding tabs on the inside as well as what we already have on the outside. And so to make this change, all we need to do is go back into our toolpath, and we can do that by double clicking on that, and then we'll use the edit tabs option. Okay, so that's automatically opened the 2D preview for us. So now we can just go in and just click in place tabs to secure the inner parts to our material. We can close that, we can calculate it, we can reset the preview this time, so I can see already that we've got the tabs added in there, and then we could go ahead and look at previewing that toolpath to see how our part will look. And so with that, we can see that there will now be no potential problems, and this should be safe to cut out. And again, this is the beauty of the previews, that we can see exactly what the part will look like before we take it over to the CNC machine. So at this stage, what we need to do is save out the toolpath to a format that my CNC can understand. So to do that, we close out of the Toolpath Preview, and then we come over to Save Toolpath. So in the list, we can see the toolpaths to be saved, and there is our profile 1/8" end mill toolpath, which is this one here. The reason it's pulled it up is because it's highlighted. So all we need to do now is choose an appropriate post processor for my machine to save this toolpath into a format that your machine will understand. So here we're going to use a drop down list. We've got lots of different post processors in the list here. In this case, I'm going to go with the G-code arcs_inches.tap file, and then we'll go ahead and save that out. Okay, so we're going to save that out using the same name. I can press save, and if I press save again, we can see that .tap file that we've just saved in that project folder. And it's this file that I'll then transfer over to the CNC to machine the wingspar. So let's just cancel out there, and then we'll close out of the Save Toolpaths form. And so with the toolpath saved, it's best practice to save the file as well. So we'll go over to File, Save As, and in the Project folder, I'm going to call this one Wingspar Getting Started, save it out, and you can access that from there.